Question 38. Now this one's going to take a little while. First we've got to read through it. We've got a couple of particles A and B is below A. So we're going to read through that first of all. Here's A and here's B. Now A's got a mass of 10 kilograms, so we've got 10g pulling that down, and we've got mg from this one here pulling down. And they're connected by a light string. Now that string's got no mass, being light, but it does have some tension in it. And so there's tension pulling B up, and there's tension pulling A down. We're also going to apply a force of 150 newtons vertically upwards on A. And what it does, it makes the whole thing move 3 meters per second upwards. Now you can look at this whole thing as one big system, but it's going to be more useful to look at it at two separate systems. And first of all, let's look at what's happening to A. And A, I would say, was going upwards. We've got 150 newtons pulling it up, but we've got 10g going down, and we've got the tension pulling it down. That is the resultant force. And of course the force equals the mass times the acceleration. The mass of this one is 10 and the acceleration is 3. And so that's what's happening at A. We'll do the same at B. Now the only thing pulling B up is actually the tension. Going in the other direction is mg, and that equals the mass, well the mass here is m, times again the acceleration of 3. Now with these two equations, if we add these two equations together, we can combine it into one bit. And combining it into one bit is incidentally what you would have got if you had have ignored the tension here, but you would have been missing out this vital first step. So we've got 150 here, minus 10g, minus tension plus tension cancels each other out, so minus mg. And on the right hand side I've got 30 plus 3m. A little bit of rearranging then. 150, take away 10g, and I'm going to take away the 30, equals 3m plus mg. I'm trying to find out what m is, so I'm going to factorize out the m there. That's m lots of 3 plus g, and then we can divide. So I've got 150, take away all of this, just tap that in the calculator now, divide by 3 plus g, or that's about 12.8, and the grand total of all of that when you tap that all into the calculator is 1.7 kilograms. Now, we now know that the mass is 1.7 kilograms, so we can actually find out what the tension is quite quickly now. We could just actually put it straight back in. Sorry, just stick the 1.7 straight back in there, 1.7 there, 1.7 there, add those things to both sides, and you can find out that the tension was 22 newtons. Alternatively, you could just look at this one here. This one hasn't got anything else. You don't need the mass for that one there. So we've got 150, take away 10g, so take away 98, and then take away 30 equals the tension. Again, tension is 22.